Hi everybody, this is Ratan Gupta from Knowledge Varsity, and in this session I will be discussing about the regression analysis using Excel. Okay, so we know about the regression, wherein in regression we are saying that there is a relationship between a dependent variable and an independent variable. However, we would want to understand how a relationship can be quantified. So Excel helps us in quantifying that relationship. So we have a data set for a bank. Okay, so in this data set what we have is you have a account balance. So these are the account balances of the various clients. Okay, and this you have is the number of transaction through the ATM that the client does in a month. So this is the average account balance in a month, number of ATM transactions done in a month. Okay, then we have whether the client has a debit card or not. Okay, so 0 stand that it does not have a debit card, 1 means that he has a debit card. Okay, then we have the number of other bank services used. Okay, so what are the other bank services that are used by the client? Okay, so if you have the 4, it means that there are 4 other services that the clients are using apart from having the account with the bank. So the number of other services are, like, if it is 4, okay, so it means that number 4 other services are used. And the last one is whether the client is receiving interest from his account, from this account or not. Typically you will find that, okay, there are mostly interest accounts. Okay, however there can be some accounts which does not pay any interest. So 1 stands for paying interest, 0 stands for there is no interest that is being paid. Right, now how do you analyze the regression for this? So please note that, like, we have different type of regression. First regression that we'll be talking about is the simple linear regression. Whenever we talk about the regression, our understanding is of the linear regression. Okay, now I am not going to go through the theory of the regression, but here I will just apply the Excel data analysis toolpak to find out the simple regression. In a simple linear regression, what we have is we have one independent variable, usually denoted by x, and what you have is y is denoted as dependent variable. So you will say that y is dependent on x. Okay, here we will want to find out if there is any relationship between the account balance and the number of ATM transaction that is done with by the client. So we understand, okay, what could be the relation. So the relation are actually expressed as y equal to a plus bx. Okay, so you are saying that y is the account balance and x is the number of ATM transactions done. Okay, or it, please note that it's not necessarily that the relationship is like, okay, if y is dependent, so we have that x is independent and y is dependent on x. Okay, it may happen that there can be interdependency, but we will say that, okay, x is what is driving y. Okay, here we'll say, okay, if number of ATM transaction, okay, is in one way trying to say what would be the account balance. So we are saying that, okay, if you have a number of ATM transaction, if it is higher, does it mean that you have a higher account balance, etc. We'll try to see. So y equal to a plus bx is what we are trying to find out. Now a and b are the output of your regression. So these are the output of your regression. Okay, and the regression analysis, it produces this. Okay, now many times what happens is, once you have done the regression, you will have to try to understand the theory behind it. Okay, here we are saying, okay, that there is some relationship, economic relationship between these two. Many times it may not happen that there is some economic relationship, but you may try to get you may get a relationship. Okay, so here if I want to understand that how these two variables are moving with respect to each other, we can use one of the features of Excel, that is, we can draw a graph. So what we can do is we can draw a scatter graph and see whether there is relationship or not. So for drawing this scatter graph, what we'll do is we'll select these two column. Okay, and then you will find that there is scatter over here, so we can put insert scatter. So I will just put this simple one so that it will give me a relationship between the two. So what we find over here is, in this case, you have number of ATM transactions, okay, on the and you have the account balance. So typically what happens is, you have, as the account balance is increasing, you find that the number of ATM transaction is also increasing. So you will get to know, okay, so that means there is some type of positive relationship between the account balance and the ATM transaction. So what you have is, as an increase in the account balance, it implies that the ATM transactions are also increasing. So here you will find that, okay, so there is a positive relationship between the two. Okay, now let us see how we can use the data analysis tool pack to do this. So we'll go to data analysis, regression, and in this regression they are asking for what is the input range. Okay, so input y range, so y is like your values, okay, and input the x range. X are the independent variable and y are the dependent variable. So here we are saying that, okay, our independent variable is this, okay, and our dependent variable is this, and our independent variable is this. So I have just put regression. Note that there is, if you see over here, there are many of the things that we have to see. First is this labels. Okay, labels means whether the first row is a label or actual data. Okay, we'll see that if I don't select this, if I don't check this, what will be the problem, right? And then the second one is, it's saying that constant is 0. That means what we have was a plus bx. So it is saying that if you say that constant is 0, they will apply constant as 0, and then they want to identify. This one is trying to find out the 95% confidence interval of your a and b values. Okay, then the output option, what is the output range? Okay, you can put it over here, you can put it in worksheet, new worksheet, or you can create a new workbook entirely. Okay, let us now not worry about the residuals. Please note that residual is actually a what is known as error. Okay, so if you have this is your regression analysis, a plus bx, but many times what happens is, the actual value will not correspond to this. Example is, suppose a plus bx give you this straight line, and one of the value you have is actually over here. Okay, so you are trying to predict this value. Okay, so this is the value that you are predicting, but the actual value comes as this. So this is your error. Okay, so this is what is called as your error. So, or residual, so we'll say, okay, these are the residual, so you can plot the residual, etc. But the idea of this video is not to get into detail of either residuals or the normal probability. So as of now we'll leave them. Okay, so once we are done with this, so let's remove this checkbox in the label and see. Okay, so please note that they are saying that regression x range and y range cannot overlap. So I think that I may have do a range overlap of this. We'll just check. Yes, so this is C and this is CF. So it means that the input range is not actually selected well. So we have this as the input range. Okay, and what we have is the input y range. Okay, y range is actually this value, so by mistake it got selected, right? So here if you see, I have started with the first row, but I have not put the first row, and I am pressing OK. So it says that input range contains non-numeric data. So whenever you see this non-numeric data, just think that you have selected this row also and have forgotten to mention that it has labels. So you will do that correction and will say that, okay, it has labels. Okay, so just check this and then press OK. What you get is, this is the summary output that you get. Okay, so this summary output is what is useful to us. It is actually a kind of a ANOVA table that comes. So this is kind of repeated, we can erase it. Okay, right. So what you have is, like, for any regression you will find that, okay, there is something r square of the regression. Okay, so r square of the regression tells us how good is the fit. So r square of the regression, if it is 0.5, it means that 50% you are able to explain. So it means that we are able to explain 50% of the variability in y from x. Okay, now in case of multiple regression, what happens is r square is not useful. Okay, so we have some adjusted r square, but that we'll see in multiple regression case. In a single regression, this is important to us. Okay, and you see over here something is given as multiple r, multiple r is nothing but the correlation coefficient between the y and x, and this correlation coefficient is actually given as root of r square. Okay, so if you take the root of this, you will exactly get this value, and we'll do the correlation analysis also, and we'll see that. So square root of this, it will give you exactly this value, right? So the r, multiple r is root of r square. Okay, this is a standard error, that we'll see the standard error, and the number of observation was 60. So this is the regression statistics. Then next comes your ANOVA. Okay, please note that in regression analysis, ANOVA is very important. It helps you in understanding about what is how the regression is doing. So regression, the degree of freedom is the number of independent variables. So in case of regression, the degree of freedom is the number of independent variable. Here we have only one independent variable, that is the number of ATM transaction. Okay, the residual and you have to see the total. The total is actually given as the n minus k minus 1, where n is the number of terms, that is we had 60 number of observation, k is the number of independent variable, and 1 minus. So if you see 60 minus k independent variable minus 1, so that is what you have is your, sorry, not total, it is your residual. Okay, and your total is actually n minus 1. Always note that the total is n minus 1, residual will be n minus k minus 1, and regression will be equal to k. So these are your degree of freedom of all these. Okay, then they are saying that what is the sum of square of the values of the regression, mean sum of square. Okay, and this gives you the f statistics value, and this gives you the significance of f. Okay, now please note that this is very low, very low. It means that our regression analysis is good. Okay, now the next table, it provides you with the coefficient. Okay, remember we said that the coefficient will be a and b. So we are saying that intercept is a, which is 485. So intercept is 485, and number of ATM transaction coefficient is 98.51. Right, so it says that the account balance is equal to 485 plus 98.51 into the number of transaction that is done. So this is the what it means by the regression analysis. Now however, if you see, it is not always these values that you get from the regression are correct. Okay, so you have to see what is the t statistics and the p value. In fact, rather than seeing the t statistics, it is better if we see the p value. Please note that the lower the p value, the better it is. So ideally I want this p value to be as low as possible. If you see over here, the p value is very less. It is 0.001. It means it is 0.1%. That means this intercept is 99.9% correct. Okay, we'll say that we are confident that 99.9% this intercept is correct. Okay, and if you see this number of ATM transaction coefficient, it is very less. It means that the chances of this number of ATM transaction coefficient of 98 is very likely. Right, so this gives you an idea. Let's say if I am doing, so we'll see sometimes your intercept p value, instead of this, if you suppose the intercept p value comes as 0.08, okay, it means that your intercept is only 92% correct. How we got this 92%? We have got is 1 minus 0.08, so we have got this as 92%. Now whenever you do the regression, you do the regression with certain confidence level. So we do with certain confidence level. Okay, so our confidence level is, let's say if it is 95% and we are getting this p value as 0.08, in that case I will say that I would not accept whatever this coefficient has given. Okay, because this coefficient would be correct with 92% probability, but my probability is higher at 95%, so I should not consider this coefficient. Right, so please note that whenever you are doing a regression analysis, focus on this p value and the significance of f. That would give you an idea as to how good is your regression. Normally the p value lesser, okay, is p value if it is lesser, as low as possible, it is good. If you are testing at 95% confidence level, you want the p value to be lower than 5%. If you are testing at 99% confidence level, you want your p value to be less than 1%. That is the idea of the regression analysis. Okay, and then the next you have is, you have been given the confidence interval, the lower 95% confidence interval. So if this is your coefficient 485, okay, what are the range? 95% range. So we are saying that the lower range is 198 and the upper range is 772. So 95% time the value will be between 198 and 772. That is what you can say. Similarly, for the number of ATM transaction, the coefficient of that, you can say that 95% it would be within these two values. Okay, so the process of this regression analysis is very simple. You will select the data, you will select what are your what is your y variable, what is your x variable, and you would get this analysis. So what is important is how you analyze this. Okay, and this multiple r is actually the square root of this. We will say that this is correlation coefficient. How do we get it? If I do the data analysis and I go to correlation and I select OK, labels in the first row, OK, so you find that it has given you the correlation coefficient of all these values. Okay, just what you see over here is the number of ATM transaction and account balance, whatever the correlation coefficient, 0.7089, so which is exactly this, right? So it is saying that these are highly correlated. Higher ATM transaction means you have higher account balance. That is the idea that you have. Okay, right? So this correlation analysis, the scatter plot, it helps you in understanding initially, and then you can delve deeper and can do the final regression. Okay, so this was Ratan Gupta from Knowledge Varsity covering the simple linear regression. Thank you.